13A from your review. Question says to factor. So our first step, we look for a common factor. Is there a common factor of 6x squared minus 19x plus 10 besides 1? No. 19 is a prime number, so the only factors that are whole numbers are 19 and 1, so we can't take a factor out of that. So we're going to try our quadratic factoring. We'll write the factors of 6 up first, so 1 and 6, 2 and 3. Factors of 10, 1 and 10, 2 and 5. Thank you. And needs to add to get our negative 19. So, exact same thing we thought before. We're just going to trial and error through this, okay, guys? So we have our columns of factors. We're going to trial and error. We'll use our very first column, our 1 and 6, and we'll multiply by the columns in the other one. You can almost think of this like FOIL. So we'll go 1 times 1 and 6 times 10, 1 and 60. There are no combinations of 1 and 60 that are going to make 19. Go back from there. 1 and 10, 6 and 1. 10 and 6, no combinations. Let's go to the next column. 1 times 2, 6 and 5, 2 and 30, not going to work. 6 and 2, 1 and 5. 12 and 5, no combination of 12 and 5 are going to work. So, I know that this first column is now no good. Definitely not using the first column because none of its factors, when I multiplied them, work. So I'm for sure using this column now, 2 and 3. So we know we're going to eventually have a 2x and a 3x in our factors. I can even go right ahead if I want it right now. And I could put in a 2x and a 3x. We just don't know what the other two factors are going to be. So same idea, multiply across. 1 times 2, 3 times 10, 30 and 2, no good. 2 and 10, 3 and 1, 20 and 3. I could get 17, but still not going to work. 4, 3 and 5 is 15. Here we go. We have a pair of factors that are going to work. A combination of 4 and 15. I need to get negative 19. So if I had negative 4 plus negative 15, this would work. I would get to negative 19. I look at my constant at the end, so my 10 here, I have positive 10. So there are two types of factors that make positive 10. 2 times 5, so positive 2 times positive 5, or I can use negative 2 times negative 5. Negative 2 times negative 5 will make our positive 10. And when I multiply 2 by negative 2, I'll get negative 4. 3 times negative 5, negative 15. Negative 4 plus negative 15 gives us our negative 19. So my numbers I'm going to use now, this is the part where some of you are getting confused. These are my columns, the two that I've circled in blue. So those are the numbers I'm going to be using in the brackets. The numbers on the outside, my 4, 15, 19, these are just a check. I don't use any of those numbers in these brackets here. They do not go in the brackets. They're just a check. Okay? My numbers in the blue columns now. So I already put in my 2x. We saw from above my 2x. I already put it in. And my 3x I've already put in. Now I have to look at what I multiplied by. I multiplied 3 times negative 5. So that means the negative 5 has to go into an opposite bracket of the 3x. So my negative 5 has to go over here. It can't be in the same bracket because we multiplied those two numbers. It works the exact same with the 2. We multiplied 2 by 2. So our negative 2 cannot go in the same bracket. It has to go in the other one. So I've now created my 2 brackets and my factors. Whoops. 2x minus 5, 3x minus 2. Okay, 16D from your review, it says to factor, but in order to factor this, we are going to need to expand. Actually, we don't have to expand. We could factor right off the bat. There's a couple ways you go about doing this. You guys could expand and simplify and then factor the question. Or you can notice that if I just look for the factors in here, let's say, so I put a little pair of brackets around, I could pull out x minus 2. So I could pull out x minus 2, and I'd still be left with x minus 2 plus 6 plus 9 in the end. This is a little more confusing, so I'm going to expand and simplify just because that's what you guys will be a little more used to, okay? If you guys noticed, there was an x minus 2 and an x minus 2 in brackets. I know that one looks a little confusing. You could pull it out. You want to have a question set up like this. So let's expand and simplify, and then let's try factoring it after. You won't have something this complicated. Let's do it anyways, though. X minus 2, x minus 2. We'll distribute the 6, so I'm going to try to do this as quickly as possible. When I distribute the 6, I'll have 6x minus 12 plus 9 on the outside, okay? I FOIL this. I got x squared minus 4x plus 4 plus 6x minus 3. I drop the brackets, x squared, 1. Okay, I skipped a lot of steps there. I'm going to talk you through what I did. When I FOILed this, I got x times x is x squared. I then did x times negative 2, which is minus 2x. Negative 2 times x is negative 2x. When I put them together, I get negative 4x. Do you guys follow that so far? Ramel, Lewis? I know you guys asked about this. Yeah, okay. Negative 2 times negative 2 is positive 4. So I FOILed the first part. The second part up here, I distributed the 6, so we got 6x, and we got negative 12, so that's how we ended up with this. And we just brought down our positive 9. So after I FOILed this part and got this answer here, I simplified the outside of our brackets. We still had only a 6x, but I took negative 12 plus 9 and ended up with negative 3. Okay? Once I dropped the brackets, there was only an x squared, so I left it at the beginning. I then had negative 4x plus 6x. Negative 4x plus 6x is going to be positive 2x. And then I had positive 4 and negative 3. They're going to equal positive 1. So I did a lot of mental math there. Okay? Hopefully you guys followed that part. Now when I've done this, I look for a common factor. Common factor, only 1. I can't take a common factor out. Anyone know what kind of factoring I can use for this? Can I find the square root of the first and the last term? What are they? 1. They're both 1. I can find the square root of this term, square root of this term. When I find those square roots, they both be 1, so I'd have 1 and 1. When I add those together, do I get the term in the middle? Or when I multiply them by 2, do I get the term in the middle? Maybe that confuses you. Let's go to our normal style of factoring. Let's try this. 1 and 1, 1 and 1. Let's do it this way. This will answer your question directly, John, okay? I took the factors. Remember you asked when to know when I can do special cases? Oh, you? Sorry, Thomas. Okay, this will answer directly. Technically, this is a special case, but let's say we didn't notice it. So we go to our quadratic factoring. I'll put my factors of the first term, 1 and 1, 1 and 1. Well, obviously, I'm using these two columns. There's only two columns there are. So 1 times 1 is 1. 1 times 1 is 1. 1 plus 1 gives me my 2. So that works out nice. In my brackets, I'm going to have 1x and 1x, and I don't have to include the 1. And because they're both positive, I'm going to have positive 1 and positive 1. So when I go to rewrite this, x plus 1, x plus 1, well, since they're duplicates of each other, this is how we did our special factoring. Since they're duplicates, we can make this even simpler. X plus 1 squared. So even though this was a special case, I used our normal style of factoring, and I was still able to get to my special case answer, where I had x plus 1 squared. Okay? So if you can't tell if something's a special case, you can still do our normal style of factoring. You'll still end up at the exact same answer. Okay, guys? The only one that doesn't work for it is difference of squares. You have to be able to recognize the difference of squares. Guys got any questions? From this part down, it will. This is really culminating. If you guys can do this question here, you should be pretty good for the test. Okay?